Alright, for example 5, our sketch is going to get a little more complicated. X over, all of a sudden we have a trinomial. So I'm going to cheat a little bit and go to my graphing calculator and just plug this in to begin with, just to get an idea of what it should look like. X divided by, make sure you're putting in your parentheses, x squared minus x minus 2, and we'll go ahead and graph this. Okay, so it's going to look like this shape here. 3 parts to it, and so we have a general idea now of what our graph should look like when we're done. So let's go in there and figure out what the asymptotes are, what the intercepts are, and we'll make sure that the general shape is what we got off the calculator. Alright, so first thing, if we look here, we're going to say for our, excuse me, sorry about that. Stop that. Come back. Will you behave yourself? Yes, alright. So for our intercept, we're going to look at the numerator and say x equals 0 from the numerator. That is our x-intercept. Okay, so first thing we look for. Second thing we're going to look for are our asymptotes. We can't get those until we factor the denominator here. So we can factor this as x minus 2 and x plus 1. So 2 different things going on here. If we find the vertical asymptotes, we're going to have x, for asymptotes it's going to be equals, x equals 2 and negative 1, and our horizontal asymptote is going to be y equals, let's take a look at the degrees here. It's 1 over squared, so we're going to divide the coefficients. 1 divided by 1. I'm sorry, that's not the way it works. If the denominator is bigger, 1 is bigger than 2, automatically we say y equals 0. When would we divide the coefficients? We divide the coefficients if the degrees are equal. So if it was x squared over x squared, we would go 1 divided by 1. If that's confusing, come back into class, we'll clear that up. In any case, the horizontal asymptote is y equals 0. We've got enough to do a sketch here. We've got 2. We've got negative 1. We know we don't cross y equals 0. And so if we flip back, just as a reminder of what the graph looks like, we're looking at it here. And so it's going to go like this. And it's going to go like this, I think. Am I doing that right? Yes. And so in between, it goes like this, which introduces an interesting point. I thought we couldn't cross the horizontal asymptote. That's definitely true. And so right here, right on the line, we're actually going to have a little hole. We're not going to cross that point, okay, because we cannot be at y equals 0. All right, so that's our sketch. Let's go ahead and see if you can do a tough one as well on problem 39, 4s over s squared plus 4. All right, here we go. Let's take a look. Let's state the domain right off the bat here. We're going to say, for part A, s squared plus 4 does not equal 0. S squared does not equal negative 4. And so the only thing we got here is 2i, plus or minus 2i, imaginary numbers. We're graphing this in the real number plane, so there are no places where it's not going to work. And so anything we plug in for s will work, and so the domain is going to be all reals, knowing that there's a couple imaginary numbers where it doesn't work, plus or minus 2i, but all real numbers is our domain. For B, let's identify our intercepts. We've take the denominator and say 4s equals 0, and in this problem we can say 4x equals 0. And so we divide by 4, and x is going to be equal to 0. That's going to be our x-intercept. All right, problem C, let's find some asymptotes. We're going to look at if we look at the denominator, s squared plus 4, from part A over here, where we couldn't find anything, there are no vertical asymptotes. Doesn't equal 0 on anything. There is going to be a horizontal asymptote. Is going to be 1 is smaller than 2, so automatically y equals 0. And so let's sketch this thing. I've gone ahead and put it on the graphing calculator just to take a peek. And I'll bring that up. Where are ya? Oh, did I lose it? Looks like I did. Let's bring it back up. It's going to look something like that. All right, so the asymptote at 0. And so if we come back here and graph this, it looks like this. We said that y equals 0 was the asymptote, but we also said it had an x-intercept right here at 0. All right, so this is going to be allowed, because if we plug in 0, we'd have 0. I apologize that this pen is really not working right now. Let's see if it'll work now. If we plug in 0 for s, we'd have 0 over 0 plus 4, which is 0 over 4, which is defined at just 0. So it will cross here at 0. But then, on the ends, it's just going to get really close to 0, but not come back and touch it. Again, we're cheating because we're going to use the graphing calculator to show us the general shape, but we found the asymptotes and we found the intercepts. That's the key.